Musking. When threatened, many snake species empty their cloacal glands, releasing a foul-smelling musk made of proteins, lipids, and sulfur compounds. Here's how it works. The snake contracts muscles around two glands at the base of the tail. The discharge is immediate. The smell is overwhelming, described as rotting fish mixed with skunk spray. Predators like foxes and birds often retreat instantly. Some species, like garter snakes and king snakes, combine musking with thrashing to maximize coverage on the attacker. The defense is cheap, reusable, and doesn't require venom or size. It's one of the most common first-line tactics across snake families. Next up, when smell isn't enough. Tail rattling. You don't need to be a rattlesnake to rattle. Over 50 snake species vibrate their tails against leaves, grass, or dirt to mimic the sound of a venomous rattlesnake. The mechanism is pure muscle control. Rapid oscillation of tail muscles at 50 to 100 Hz. When the tail hits dry vegetation, it produces a buzzing rasp that sounds strikingly similar to a real rattle. Species like rat snakes, hognose snakes, and even some pythons use this bluff. Predators, especially mammals, often back off without verifying the species. The rattlesnake's reputation does the heavy lifting. It's evolutionary mimicry without the cost of growing actual keratin rattles. Next up, a biological smokescreen. Cloacal discharge, also known as defensive defecation. Snakes can forcibly expel feces and urates as a deterrent. This isn't accidental. It's weaponized. When grabbed or cornered, snakes contract abdominal and cloacal muscles to launch semi-liquid waste at the threat. The mixture contains uric acid, bacteria, and undigested matter. It's messy, smells worse than musk, and sticks to fur and feathers. Raptors and mammalian predators often drop the snake immediately. Species like water snakes and green snakes are especially prone to this. It's gross, effective, and forces the predator to spend time cleaning instead of eating. Next up, the ultimate bluff. Thanatosis, commonly called playing dead. Hognose snakes are the masters. When threatened, they flip upside down, open their mouths, let their tongues hang out, and go completely limp. They may even release blood from their mouths and emit a rotting smell. The performance is deliberate. The snake monitors the threat and only dies when it believes it's being watched. If you flip it right side up, it flips back over. The tactic works because many predators avoid carrion or lose interest in non-moving prey. This isn't limited to hognoses. Grass snakes in Europe and some Asian rat snakes also feign death. The trick? Commitment. Half-hearted death acts don't fool anyone. Next up, when you can't fight, you advertise. Aposematic coloration. Nature's warning label. Bright colors aren't just for show. Coral snakes, sea snakes, and many venomous species use red, yellow, and black patterns to signal danger. The message: I am not food. Here's why it works. Predators learn through trial and error. A bird that tries to eat a coral snake once and survives remembers the pattern. Over generations, the entire predator population avoids those colors. This is Batesian mimicry in reverse. The dangerous animal advertises honestly. Non-venomous species like milk snakes and king snakes mimic these patterns to piggyback on the warning. The real question: did the predator learn the lesson? Body flattening. When cornered, many snakes spread their ribs outward to appear larger and more intimidating. The cobra is famous for this, but it's not alone. The mechanics: snakes have flexible ribs not attached to a sternum. By contracting intercostal muscles, they can splay ribs horizontally, doubling their visual width. Some species, like hognose snakes, flatten their necks into triangular hood shapes. Others flatten their entire bodies into ribbon-like profiles. The illusion works on visual predators. A wider snake looks harder to swallow and potentially more dangerous. Combined with hissing or mock strikes, it's a full threat display. Next up, the invisible escape. Cryptic behavior, freezing in plain sight. Movement attracts attention. Many snakes rely on camouflage and complete stillness to become invisible. When a predator approaches, they lock their muscles and stop breathing visibly. This works because most predators hunt by detecting motion. A frozen snake blends into leaf litter, bark, or sand. Species like gaboon vipers, copperheads, and green tree pythons have patterns that disrupt their outlines when motionless. The risk: if the predator steps too close, the snake must switch tactics instantly, usually to striking or fleeing. Freezing only works when the camouflage is good and the predator is moving. Next up, when hiding fails, go loud. Hissing. Snakes don't have vocal cords, but they can force air through their glottis, a small opening in the throat, to produce a loud, sustained hiss. It's pure acoustic intimidation. The sound is amplified by the shape of the mouth and throat. Larger snakes produce deeper, louder hisses. Some species, like puff adders and king cobras, can hiss loud enough to be heard 30 feet away. The message is universal: back off. Hissing is often paired with other defenses. striking, flattening, or rattling. It's a low-cost, high-impact warning that works across species barriers. Mammals, birds, and even humans instinctively react to the sound. Next up, toxic skin secretions. A few snake species secrete toxins through their skin. The Asian keelback snake is the most notable example. It sequesters toxins from poisonous toads it eats, then stores them in neutral glands on its neck. When attacked, the snake raises its neck and releases bufadienolidide toxins, the same compounds that make toads poisonous. Predators that bite the neck get a mouthful of chemical deterrent. The snake doesn't produce these toxins itself. It borrows them from its prey. This is rare because it requires a specific diet and specialized glands. Next up, the false head gambit. Tail display, the decoy head. Some snakes hide their real head and raise their tail to mimic a second head. Rubber boas and sand boas are famous for this. Here's the setup. When threatened, the snake coils into a ball, tucks its head in the center, and raises its blunt tail. The tail looks like a head. It's the same size, same color, and moves in a searching motion. Predators strike the tail instead of the real head. The tail can take damage. The head cannot. Diving and aquatic escape. Water snakes and sea snakes use water as a three-dimensional escape route. When threatened on land or near the surface, they dive deep or disappear into underwater vegetation. The advantage: most terrestrial predators can't follow. Even aquatic predators lose track in murky water. Snakes can hold their breath for 30 minutes or more, some sea snakes even longer. They use submerged rocks, plants, or mud to break line of sight. This only works near water, obviously. But for species that live in wetlands, rivers, or oceans, it's one of the most reliable defenses available. Next up, pure speed. Rapid retreat. Just run. Sometimes the best defense is not being there. Many snakes are faster than you think. Racers, coach whips, and black mambas can move at 10-12 miles per hour in short bursts. The strategy is simple. Detect the threat early, orient toward cover, and move. Snakes use lateral undulation to generate speed across open ground. Mock strikes. The fake out. Many non-venomous snakes strike with their mouths closed or pull the strike short. It's a bluff, designed to make the predator flinch and reconsider. The strike is fast, loud, and looks real. Hognose snakes, bull snakes, and rat snakes all use this. The snake may lunge forward, hiss, and snap its jaws, but never make contact. The goal is intimidation, not injury. Predators, especially inexperienced ones, often retreat. The illusion of danger is enough. Tail autotomy, sacrificial escape. Some snakes can voluntarily detach part of their tail when grabbed. The severed tail continues to wriggle, distracting the predator while the snake escapes. This is rare in snakes compared to lizards, but it occurs in species like glass snakes and some burrowing snakes. The break happens at predetermined fracture planes in the vertebrae. The tail thrashes for several minutes due to residual nerve activity. The cost is permanent. Most snakes cannot regenerate a full tail. They regrow a stub at best.